All right, everybody, welcome back. Today I want to start the inventory inventory system. I would like to start being able to make things items before we get too further deeper into the series, right? Because when I want to do weapons, when I want to do like potions and stuff to restore my health and other status effects and stuff, like I don't want to make everything to just walk up and have it disappear. I'd like for it to be items. So let's start by coming into our C++ classes, public section, a new C++ class, and this is going to be an actor component. And the actor component right here is just going to be called inventory component. And we're going to put this in the inventory section. I do not need this to tick. Let's see about that. These. Oops. Don't want to get rid of that. Set this to false. Okay. Now, how I want to design this inventory is based off of gameplay tags, right? Um, so I want to do a tag map. Gas runs runs a big, massive tag map for all your gameplay tags, and you can determine so much of the player off these gameplay tags. So I'd like to treat inventory the same way because I know it can get complex and out of hand. So I'd like to be able to just kind of keep track of everything nice and neat. So we're going to start by doing it like this. We're going to make a private section, and we're going to make a variable as a tmap of f's gameplay tag, and we're going to add an include for that, and it's going to be to int 32 is the values, and this will be inventory tag map. And then we need a u property, and this is going to be blueprint read only, and meta equals allow private access to true. So we're going to do that. And now that we have a tag map, we're going to make a public function, and it's going to be void, and we'll just call it add item. And it's going to take a const f gameplay tag by reference called item tag. And then it'll take an int32 called num items, and we're going to set that default to 1. And we are going to make this a u function. It'll be blueprint callable. So now that we have add item, the thing is, we're doing multiplayer, and we don't want to let clients add items, right? We don't, because I don't want to let the client potentially just keep forging its own items. So what I'd like to do is we're going to make our first, well, this RPC here, has to be void, and this is going to be server add item, and again, it's going to take a const f gameplay tag by, whoa, get rid of that, excuse me, const f gameplay tag by reference called item tag, and then it'll take an int32 called num items. This has to be a u function, and then server reliable. Okay, oops. Now I'm going to generate definitions for these, and you're going to see that writer auto includes underscore implementation when you do your function names for RPCs. So it's server add item underscore implementation. That's the function body you have to write. So add item. The first thing I want to check is I want to say actor. I want to make an actor pointer, call it owner, and we're going to equal to get owner. And then if we say if not get, or excuse me, if not owner, and of course we could be nicer and say it's not is valid owner, then we're just going to do an early return just to get out of here, just in case, right? And then the next thing we're going to check on the owner is we're going to say if not owner, and on the owner we're going to ask has authority. So if we're on a client, then we're simply going to say server add item, and you must just call the regular one. Do not call implementation, call the regular body. And it needs, we're just going to keep passing the item tag along and the num items along. And then if it does hit that, we're just going to return at that point, right? So we come down to server add item, and what are we going to do? We're just going to call add item and pass it the item tag and the num items. Now, why do that? Well, because easily now we just continue this function body for add item, and we know that anything we write below this line is only going to be done on the server, right? The client, as soon as they call the same function, is just going to send it to the server to do it. So we're going to ask ourselves real quick, we're going to look into if the inventory tag map we can call dot contains, and we're going to look at the item tag, right? If it contains the item tag, then we are going to take the inventory tag map and we're going to index it at the item tag. And we're going to say plus equals num items. And then you can say else. So if the inventory tag map doesn't have that item tag, then what we could do is say the inventory tag map, you can call dot in place so that we make sure there's no duplicates made. So we can in place the item tag and the num items. Okay, so what I want to do just after here is I want to say g engine. I just want to add an on-screen debug message. The key is going to be -1. The time to display can be 5.f seconds. We're going to use an F color of red, and the message, it needs to be an F string that we're going to just call printf using the text macro. No, using the text macro. And here we're going to say item added to inventory, right? And then we could say type specifier S for string, and then you could say quantity, and then we could do type specifier for D, and that's for integers, right? And then we can get the item tag, oh, excuse me, we need the star item tag dot to string, and then we can just do num items. Oh, forget a parentheses, excuse me. So basically we're just gonna see added item when it gets to here, what it looks like. Okay, so now we have a tag map, and we have a function that can add an item based off of this map, whether it's there or if it's just going to add it. And then after it goes through this, it's going to tell us what is the tag name that it added and what is the number of it. So if you don't have your project open, go ahead and launch it. It should build successfully. We are going to need our next class. So we're going to get in here, and I'm going to come in here into the game folder, and I'll make a new C++ class, and this is going to be a player controller, and we can call it RPG player controller. This is player controller. We're going to create this class, and we're going to put the inventory component actually on the player controller, right? So the player controller is locally controlled and owned. We have there's the concept of authority and not, and we can easily replicate this. So we're going to put the inventory component on the player controller. So for that reason, I'm going to make a private section, which is going to have a T object pointer to a U inventory component with a forward declaration that we're going to call inventory comp. We can be nice and say inventory component, right? And we'll give this a U property, and this is blueprint read only, and meta equals allow private access equals true. So now that I have this inventory component right here on the player controller, all I have to do is I need to make a public section where I make an A RPG player controller constructor, and I show context information, generate a definition, and the player controller, I do want to say B replicates equals to true because I do want the player controller replicated. But then I'm going to say the inventory component is equal to create default sub object, the U inventory component that we will just call inventory component. And then we can take the inventory component and we can also call set is replicated and set that to true. So our inventory is replicated. So now that we have that inventory component, what we can do is rebuild, recompile again. And now that we're back in the editor, we can come into third person blueprints, and in the player, I can make, well, I can keep this nice player state for here, and then I can make a folder for player controller, and inside player controller, I'll make a class of an RPG player controller that we can just call BP RPG player controller. Open up the player controller, and you can see here we have our inventory component, and it looks like I can't access anything in here, which means I made a type specifier issue. So I need to come back here. I made several issues on this. This needs to not only be visible anywhere, but I also completely forgot we're going to also need to replicate this. So we're just going to use replicated. We don't need a Repnotify yet to say we don't need to take any specific action once this is replicated, but that does mean I need to do the virtual get void get lifetime replicated props. And in here, I can say do rep lifetime, and it is going to be for the A RPG player controller. We are going to replicate the inventory component. So now I'm going to recompile again. Okay, so now I am going to come in here, and I didn't save my player controller. So I am going to do an RPG player controller again. That is BP RPG player controller. And now, here we go. Now my inventory is here. This is standard stuff. There's nothing custom here yet. But we can come into the event graph in the player controller, and I can say, for example, keyboard 1. I can take the inventory component and I can call add item. Now, I need an item tag. So we're going to make a literal gameplay tag, and the default is 1. We're fine with that. But we need item tags, right? I'm trying to do this all off of gameplay tags. So let's create a new section, and this hierarchy is really going to matter. You'll see coming soon. This hierarchy is going to matter how the system is designed. So we're going to say, like, first off, it is an item. So it's going to be item dot. And the first category we're going to make is a consumable, right? And let's just start by saying we're going to make a health potion. And we're going to just do an item.consumable.health potion. And we're going to, add that to that. Now, you can just right click on this and add a sub tag, and while we're at it, as a health potion, we make a mana potion, right? And then we'll add a new tag. So now we have health potion and mana potion tags. Well, we can do, I want to do a flip flop so we can see it adding both. I want to do add item and add item. But on the first one, I want to add item consumable health potion, and on here I want to add mana potion, and we're going to add one either way. Now, theoretically, how we wrote our code, it doesn't matter. We don't need to do an authority check here, right? We don't have to care if has authority, because inside the add item function, it does the check and then it does the server RPC whether you like it or not. So the server should only be adding the items no matter who pushes this button. Yeah. So we are going to come into the game mode, because we need to set the player controller to our new BP player controller. So now our player controller is sitting there, and I should be able to just add item. Let's see how it goes. We're going to do one on the server and one on the client, and it should be adding these debug messages. So we're going to hit 1, consumable health potion, quantity 1, and then mana potion, quantity 1, and then health potion, quantity 1, and mana potion. Okay, so we got it on the server. Now on the client, I can still do health potion, mana potion, health potion, mana potion. We could be a little more verbose if we wanted to, where I could print the string to say this is server, right? If we really wanted to see, we could say server item added to inventory. Let's see what that looks like just to show ourselves. So server item added to inventory, right? We're here, server added item. And then I'm on the client, but it still prints server added item, server added item, even though it has no authority. So that's the beginnings of our inventory system. We can now add gameplay tags to this map. We can add gameplay tags to this map and take it off. But the thing is, this gameplay tag map, in the world of Unreal Engine multiplayer, maps cannot be replicated. You can't send them as variables through functions. You can't even mark this. I can't mark this as replicated and try to go through the system like that. You can't do that. So in order to get around this and still be able to use this system on clients and have all the future systems work, what I'm going to come up here to the top, I'm going to declare a uStruct, and I'm going to call this an F packaged inventory, right? In this packaged inventory, I'm going to make a T array of F gameplay tags, and this will be called item tags. This needs a U property in order to be replicated properly. Do not leave out the U property. And then I need a T array of int32, and this will be item quantities. And this is also a U property, okay? So what I need to do, we're going to make a private function. And this private function is void, and it's going to be called package inventory. and it is going to take an F packaged inventory by non-const reference, and this will be called out inventory. Okay, and then I need to also maintain a copy, right? I need an F packaged inventory that we're going to call cached inventory. I need one of these, and we're going to mark it with a U property. And the only thing that we are going to say on it is that it is replicated using onRep cached inventory, which means we are also going to need a Repnotify, right? Void onRep cached inventory. And we don't need the old one, that's fine, but we do need to mark it with the U function. So we're going to generate definitions for these, and I'm going to take begin play. I'm just going to take begin play out completely for right now. I don't think I need it. So on our packaged inventory, what we're going to do is we're going to clear out first. We're going to take the out inventory that has the item tags, and we're going to empty that array. And we're going to do the same thing on the out inventory. We're going to take the item quantities and call that empty as well. So we're going to just clear it out. And then we're going to loop. We're going to say for const auto reference pair, because we're going to loop through the inventory tag map. If you want to type out, I do auto when I go through maps. I do auto because the type names are really long. So yeah, we just remember that the first in the map is the key and the second in the map is the value. So the gameplay tag is the key and the int is the value. So now that I do that, I can ask myself if the pair dot value, which is the quantity, right? If the quantity of it is greater than 0, well, at that point, then we're going to take the out inventory and we're going to take the item tags and we're simply going to add pair.key. We're going to add the item tag and then we're going to do the out inventory and we're going to say the item quantities and we're going to add the paired dot value. So at the end of this loop, what's going to happen is you're going to have everything everything that has at least one is going to be in there. So what I'm going to want to do is I am just going to call, after this, I'm going to call package inventory after I add an item, and the out inventory, we're going to keep it saved in our cached inventory. So every time you add an item, it's going to repackage the inventory and reevaluate every number for every item, right? Well, by changing the values on here, because we are going to mark this as replicated using, excuse me, I have to do the lifetime replicated props in a second, but because we're going to replicate it here, every time it's going to do that, we're going to need to optimize it a little bit, right? And then we'll figure out what to do in the Repnotify once I have it updated because the values changed. So I'm going to come here and I'm going to say virtual void get lifetime replicated props. So you can't replicate a map, but you can replicate double arrays wrapped in a struct. So we could say do rep lifetime u inventory component cached inventory. Now, the thing is, right, if we think about it for a second, that's a lot of values being traveled over the network a lot, right? Like that's constantly data every single time an item is added or anything added. And then obviously it's going to be when we remove items, every time it updates, we're going to end up sending this package network or packaged inventory across the network. So what I'd like to do is do something called net serialization. It's going to be a little bit of an optimization when this struct travels across the network. So how we do that is we start by making a virtual, and we're going to make a virtual destructor. So you need the tilde, and then you say f packaged inventory, and you just need one to say equal. So now we're able to say virtual bool. Oh, excuse me, virtual. It's a Boolean return, and it's called net serialize. right? It uses an farchive by non-const reference called R, takes a U package map pointer called map, and it has a non-const boolean called bout success. Okay, and we can just go generate a definition, put it at the top of the header is fine. We can do that. But how do we, it takes one extra step. You got to turn it on in the engine, right? You got to tell the engine, hey, by the way, this struct right here has a net serializer. So how we do this is you write under the struct right here, you say template and just put the brackets. And then we just declare a struct that's called tstruct ops type traits. And that's a template, which is going to take the name of our struct that we're doing this to, which is the F packaged inventory. And it's going to be colon like it's inheriting from a tstruct op type traits base 2. For the same thing, we're going to do packaged inventory. So now that you have one there, you just need to write enum, get rid of the name, expand the brackets, and you just say with net serializer equals true, and you leave it dead at that. Don't touch it beyond that. No, this is a very specific method. And then what are we going to do in net serialize? Well, the thing is there's not going to be really conditions that we don't want to replicate this entire map completely fully, right? There's not going to be any conditions. Every single time we modify it, we want to know about the whole thing at all times. So this is not going to be a very extensive net serialization. It's I just literally call safe net serialized T array. There's 3 options: default, header only, and with net serialize. Well, we have 2 arrays in here, right? So we're going to safe net serialize the first T array that's got gameplay tags, and gameplay tags come by default with their own net serializer built into it. So if we call safe net serialize T array with net serialize, then that means as it is net serializing the array in the first place, it will then sub-serialize all the items within the array as it goes along. So it's just a deeper layer. Now, this is a template parameter for the maximum size of the array that goes in here and as an int32. And I would like to know if someone can correct me out there truthfully. I can't figure out how to make this template integer a parameter that I can modify at runtime to really optimize this to keep expanding and contracting only the only the specific size of the array. I've only been able to just hard code a max size of the array. So what you're going to have to define here is in your game, if this is being used for the inventory, right, and you're using for all your items, you have to define right here what is the maximum number of different kind of items you can have, right? Not total. It doesn't matter if you have 1,000 items of this kind. That's considered one item in the array. So you have to determine right here, and you can always adjust it at any time, but you also have to keep in mind if there's a hacker or a cheater that wants to inject some fake stuff down the road, they could potentially, if you just set this to 99999, they could potentially forge an inventory that is that size of an array, right? So be responsible. You need to let people have enough items, but you need to also try to defend yourself from someone giving them the works. So I put 100. But the first thing, so then the first parameter that it needs that archive that it's going to write into. So we pass it the archive, and then what's the array that we're net serializing with is the item tags, because that's got with net serializer, and then it'll require the map as well. And then for the integers though, we can just say safe net serialize T array default 100. And we're going to pass in the archive as well, and then we're going to pass in the item quantities. It doesn't need the map because it's not serializing. But after that, we need to say bout success equals true, and then return true. You need to do those. And so now we've optimized this a little bit to go over the network. And our inventory component, our inventory map is just going to be deconstructed and then replicated and sent across the map. Now, when it gets to the other side of the when it gets to the other side of the fence, though, once it gets to the client, we got to do the opposite, right? We're going to have to write a void function that's called reconstruct inventory map, and it can take an const f packaged inventory reference called uh, uh, inventory. We'll just call it inventory, and generate a definition. And in the reconstruct inventory map, all I have to do is we just got to make a loop, right? We have to say for int 32 I equals 0, and then I is going to be less than the inventory that we're passing in has the item tags. We can look at the number of those, and then we're just going to say plus plus I. So that way, this is only going to run as many times as there is the number of item tags in the array. Oh, excuse me. Before we do that, we want to take the inventory tag map and call empty on it. Whenever we're reconstructing this, we need to start from scratch. So we're going to empty it first before we start putting these values in there. But then all you have to do is take the inventory tag map and we can call in place, and it's going to be the inventory dot in item tags indexed at I, right? That's the tag we're going to start, and then the inventory dot item quantities indexed at I. So now it's going to blank out the map, and then for as many item tags as it's going to run in there, it's just going to drop them, and this is going to happen in the exact same order, right? So it shouldn't randomize your inventory between server and client. It should all come in the exact same order. So now we have on rep cached inventory. We're just going to call reconstruct inventory map, and we can just send in the cached inventory, because we know on rep cached inventory now these values are updated and fresh. So now we can just do this. So what that means is the server added the item, it broke it down, and it packaged it into this inventory struct. It net serialized, blew across the network, and then updated on the client. And then the client calls this to reconstruct the inventory map. And now that the client is there, now it should have a brand new inventory tag map that should look just like the server's version. So what we could actually do is, because the only time we're calling this reconstruct right here is on the onRept, we can kind of see a little bit how this works, right? We could say G engine, and we can add an on-screen debug message with a key of -1. Print time, we'll leave it up there for 5 seconds so we can see this, and it'll be F color blue. And then our message is going to be F string print F, right? And the text is going to say tag added, and then %s, and then we can do this, and we could say quantity added, and we could say D, and then we would come out of here and we would say inventory dot item tags indexed at I dot to string, however that needs to have the star in front of it, excuse me, and then it would be inventory dot item quantities indexed at I. So what we're going to see is, when this is reconstructed, exactly what tag was added and how many quantity of that is every single tag, right? So let's recompile and give it a shot. Okay, so we're back here in editor, and I should be able to hit play, And then when I'm on the server, let's see what happens when I press 1. Looks like I'm just adding health potions and mana potions. Okay, but then when I come onto the client, what happens when I press 1? Oh, now I've got the message, right? And then now I've got mana potion. And I push it again. Now I've got 2 health potions and 2 mana potions. So the server is still adding the items 3 and 3, 4 and 4. The server is still adding the items to the inventory. But now we're getting the Repnotify and it's reconstructing the inventory with the proper amount and proper tags of the items that we're adding.